In this lesson, you will learn to memorize some fundamental definitions, as well as how to simplify, add, and subtract polynomials. So as we begin, let's begin with a few definitions and give some examples of each of them. The first one is the term constant, and a constant is simply a number. So for example, we have 2, 1/2, 0, -5. It can be positive, negative, fractions, 0. The constant can be any number. Next term is a variable, which is a letter, something like X or Y or Z or A or B. It can be any letter. And then a coefficient is the number or the constant in front of the variables. So for example, if you look at 3m squared, the coefficient would be a 3. If you look here at xy, there's an assumed 1 in the front of it, so the coefficient would be 1. For negative xy squared, there's an unwritten 1 in front, so the coefficient would be a -1. And then we have monomial, which is a constant variable or a product of a constant and one or more variables. So for example, we see here 2x, so that's 2 times x. We have a constant times a variable. It could just be a number, just a constant. So we have 1 would be an example. Or it could be a product of multiple variables with the constant. So we have 3x, y, z squared. Or it could just be y to the third power. All of these would be monomials. Now what would not be monomials would be where you divide. So like 3 over x, for example, because it needs to be a product of one or more variables. 2x to the -4th, we've not learned this yet, but the negative exponent means that you're going to divide by x to the +4th. So once again, with a negative exponent, that's going to be the same thing as dividing, so that would not be a monomial. And then here we have the square root of 2 plus x. This would not be a monomial as well. We're not, multiplying. It's just a different type of thing that we're looking at here. So if you see a square root or a cube root, those would not be monomials. A binomial would be the sum of 2 monomials. So you see the prefix bi means 2. So we have a combination of monomials. So here we have 2x minus y. 2x is one monomial, minus y is another monomial. And we can tell that there are 2 monomials because they're separated by the plus or minus sign. So here we have a 2x by itself, separated by a minus sign, and then the y over here by itself. So we have 2 monomials, so therefore that's a binomial. Here once again, we have these 2 monomials separated by a plus sign. So that's how we know there are 2 of them, because they're separated by a plus or minus. So here there's 2, so that's going to be also a binomial. Same thing for the third one, separated by a plus sign. We have 1, 2 monomials, so that would be a binomial. Trinomial is the next one, and we see the prefix tri. Tri means 3. So if we have 3 monomials added or subtracted together, then it'd be a trinomial. So here we see 1, 2, 3 monomials separated by a plus or minus sign. So that would be a trinomial. Here is 1, 2, 3 separated by a plus or minus sign. So that would be a trinomial. Same thing here, 1, 2, 3 separated by a plus or minus sign. So that would also be a trinomial because there are 3 monomials. Now those are specific examples, specific cases, and in general we have what's called a polynomial, which would be any of these. So it could be monomial, binomial, or trinomial, but then it could also be expanded to be any number of monomials being added together. So it could be monomial, like here we see an x, that's just one term. And then here we have two monomials, so a plus b. We have 2 monomials separated by a plus or minus sign. So binomial would also be a polynomial. And then here we have 1, 2, 3, 4, 5 monomials being added or subtracted. So this would also be a polynomial. There's not a special name we give to it like we do with the one monomial, or bi for 2 or tri for 3. There's not a specific name for one with 5 or 4 or any other number. So that would still, just in general though, be classified as a polynomial. Poly means many. The next term is the word term. And a term are the monomials in the polynomial. And you might have noticed, but I slipped and said the word term before I explained what it meant. But a term is each part, each monomial in a polynomial. So, for example, we see here is one monomial, here's 2, here's 3. So 3xy squared is the first monomial. We say that is the first term, or term 1. And then the second term would be the 2x, that second monomial. And then the third term would be the minus y over here. So that's another name, specific name we give to the monomials in a polynomial. The next term is the word or the phrase similar or like terms. And like terms are terms that are identical or only differ in their coefficients. So for example, we see here 2x and 4x are similar or like terms because the variable portion over here are the same, and the only thing that's different is the coefficient in the front, the number in front of the variable. So the 2 and the 4 are different, yes, but the x is going to be the same. And that's as opposed to over here, we have 2x and 4x squared. Notice this has an x, but this has an x squared. They are different. So those are different, so those are not similar or not like terms. They need to be identical with the exception of the coefficient could be different. So that would be similar or like terms. Now moving on to another kind of a definition, but a little bit of, I guess, math, so to speak. There's really not much math yet, though, in this lesson. But here we have what's called a degree of a variable, and it's simply the exponent with the variable. So for example, if you had the expression x squared, the degree of the variable x would be the exponent, or the 2 right there. So the degree of that would be a 2. If it was x or y to the third power, the degree would be a 3 because the variable is raised to the third power. If you had z to the fourth power, the degree would be 4 because the exponent here is 4. If you had a to the fifth power, the degree would be 5. And then if it was just b and there's no exponent written, remember that if there's no exponent written, there's an assumed 1 up here, right? Because there is 1b and nothing being multiplied with it, so it'd just be b to the first power. So the degree of this one would be 1. Now let's expand this to a degree of a term. Now for a term, what we do is we add all the exponents of the variables. So for example, here we see 3x squared. Here there's only one variable, and we just take the degree of the x, which would be 2. But then if you had something like this, where you have 5x to the third, y squared, we add up the degrees of the variables. So the degree of x would be 3, the degree of y would be 2, we add the 3 and the 2 to get 5. If you had x to the fifth times y to the seventh, you have a degree of 5 and a degree of 7. You add those together to get 12 for the degree of the entire term. If you had 4x to the fifth times y, you take the degree of x, which is 5, the degree of y, which would be an assumed 1, add those together to get 6. And then lastly, if you just had a number, well, there are no variables here, right? If there was an x, there would be an assumed 0, right? Because anything to the 0 power is always going to be 1. So essentially, if there's no variable, the degree is going to be 0. Okay, so take note of that, but you're just adding the degree of the individual variables. And then, expanding one step further, if you try to find the degree of an entire polynomial, what you do is you take the greatest degree of its terms after it has been simplified. So for example, here we have 10x squared plus 5x to the fourth plus 3. If you look at the first term, the 10x squared, the degree of 10x squared is found by adding up the degree of the variables. So in this case, it's just the 2. So the degree of the first term would just be 2. The degree of the second term right here, 5x to the fourth, would be a 4. And then the degree of this last term, the last term is just a constant. There is no variables, so there is no degree. So the degree of term 3 would be 0. So now, the degree of the entire polynomial, so of the entire expression, would be simply taking the biggest degree, the biggest term, the term with the biggest degree, which would be a 4. So the degree of the entire polynomial would be 4. Let's look at another example. Here we have 8x squared y plus 2x squared y to the third z to the fifth plus 4. Now here, same thing, you find the degree of each term. So this first term, the degree, would be found by adding the exponents of the variables. So the 2 plus an assumed 1 gives you 3. Term 2, you add the 2 and the 3 and the 5 to get 10. And then term 3, which would be just the 4, well, it has no variable, so the degree of term 3 would be 0 because there is no variable. So the degree of the entire polynomial would be the biggest one, which would be a 10. So the degree of this polynomial would be 10. Now, where the degree of a polynomial comes into play is when you are trying to arrange an expression in descending order. Because if you had, for example, 2x to the third plus 3x minus x squared plus 5x to the fourth, it's better to write this in descending order. Meaning, if I look at each term and the degree of each term, it's best practice to put the first term as being the term with the biggest degree. So we see here, this degree would be a 3. The degree of this would be an assumed 1. The degree of this would be 2. The degree of this would be a 4. So when I arrange in descending order, what I do is I start with the biggest degree first, and then go to the smallest degree. So what that would look like would be I'd start with the 5x to the fourth power, because that is the biggest degree. And then I put the third power, and the second power, and then the first power. So that would be descending order. And anytime you write a polynomial, it is best practice to write it in this format. Now next I'd like to show you how to simplify polynomials. And this is going to be the last part of this lesson. So what this looks like would be something along these lines, where I have different polynomials being added or subtracted together. So when you do this, okay, what you want to do is you want to get rid of the parentheses first. If there's a plus sign, if you're just adding these together, you can just automatically think of them as not being there, because a plus does not affect anything really. Okay, so these are gone, and now what I can do is I can combine like terms. So for example, like terms would be the 2m squared and the 3m squared, because they both have an m squared. And the only thing that's different is the number in the front, the coefficient. And then we can also combine the negative m and a positive m. Those are both like terms as well. And the numbers are by themselves, so we have 4 and negative 5. Those are also like terms. So what I can do is I can add and subtract as needed to combine. So we have 2m squared plus 3m squared, which gives me 5m squared. And I just got rid of the parentheses here, but I combine, I get 5m squared. And then negative m plus m, that would cancel, right? Positive plus a negative of the same thing, that will be gone. And then we have 4, then plus a negative 5, which gives you a negative 1. So my final solution would be 5m squared minus 1. Another example with addition. Now we have 3 polynomials being added together. And once again, with the plus sign, we can think of this as just without parentheses. We can just get rid of the parentheses. So that's what I've done here in this step. And then I can combine like terms. Well, let's see. The third power, there's nothing to combine with. The second power, there's nothing to combine with. We can combine 8x and negative 9x. Those are like terms because they both have just the x after it. And then we have a negative 4 and a positive 7. Those are just numbers that we can combine together. So what I can do is write this in descending order. So I start with the third power, write that first, and then write the second power second, so 4x squared. And then the x to the first power, we'll do that next. So here we have 8x minus a 9x, which would give me a negative 1x, which is what we have right here. And then from there we'll do the constant. So negative 4 plus a 7 would give me a positive 3. So this right down here would be my final answer. I've simplified by combining like terms. Now let's deal with subtraction. Now with subtraction, you just have to be careful with this. Many people will make this mistake. So please be careful and notice what I'm about to say. So we said for the addition, and for any of these, we want to get rid of the parentheses first, right? Well, here, what I have is I have subtracted this entire expression. So what that means is that the first part would stay the same, 3x squared plus 4x minus 10, but over here, I'm subtracting a 5x squared, I'm subtracting a negative 3x, and I'm subtracting a 7. So what I'm doing is I'm essentially distributing a negative 1. There's an assumed 1 here. So negative 1 5x squared, negative 1 times a negative 3x, and a negative 1 times a 7. So this negative will change the sign of everything in the parentheses because I'm subtracting everything in here. So what that looks like, it's going to be a negative 5x squared. This negative 3x becomes a positive 3x, and then a negative 7 would be here at the end. So be careful with that minus sign right there. Many people will do the minus 5x squared, but they'll forget about the minus negative 3x and the minus 7. So here, I can now combine like terms, starting with the highest degree. So we have the squared terms would be the highest degree. We have 3x squared minus 5x squared. Those would combine. And then the first power would be 4x to the first, and then 3x to the first. Those can combine. And then the constant, negative 10, and the negative 7 can combine. So when I combine 3x squared and negative 5x squared, that would give me a negative 2x squared. 4x plus a 3x would give me a 7x, and negative 10 minus 7 would give you a negative 17. So this would be my final solution. I have distributed the minus sign and then combined like terms as necessary. Let's do one more along those lines. Here we have a minus sign in between. So we're subtracting this entire expression in parentheses. So the first expression, 15x to the third minus 4x squared, will stay the same, but then the second expression will change. So here we have a minus 8x to the third minus a 9x and minus a negative 5, which becomes a plus 5. So what I have is going to be a negative 8x to the third minus 9x and then a plus 5. And then combine like terms, 15x to the third and negative 8x to the third are like terms. They both have x to the third. 4x squared, there's nothing that can combine with that. There's nothing that can combine with x to the first power, and nothing that can combine with the constant. So here the only thing that would simplify would be this 15x to the third and then negative 8x to the third. So I subtract those and I get 7x to the third, and then everything else will stay the same. And actually, not sure where the 17 came from. That should be a 5. I'm sorry, that should be a 5. All right, and then last example. Here we have a number in the front of the parentheses as well. So that's the only thing that's different in this example, and this is the last example for this lesson. So remember we said when you're simplifying polynomials, you want to first get rid of the parentheses. Well, to do that, I would like to distribute the 4. So multiply 4 times 3y squared, 4 times negative 2. And then also distribute this 3. So 3 times y squared, 3 times 5y, and 3 times a negative 1. So when I do that, I'm going to have a 12y squared. 4 times negative 2 is negative 8y. 3 times y squared would be 3y squared. 3 times 5y gives me 15y. And 3 times negative 1 is negative 3. So I have gotten rid of the parentheses, which now allows me to combine like terms. So 12y squared and 3y squared are like terms. They both have just the y squared. And then we have negative 8y and a plus 15y. Those are also like terms. And the negative 3 cannot combine with anything. So 12y squared plus a 3y squared would give me 15y squared. Negative 8y plus 15y would give me 7y. And negative 3 would be out by itself. So this would be your final solution. And that concludes our lesson for today. So we will see you next time.